Hello, my name is Walter Unglaub, and this is how do you find percent by mass with given percentages. So if we consider air as an example, we know that by volume, approximately 78% of the air is composed of nitrogen, which comes in the form of the diatomic molecule N2. 21% by volume of air is oxygen in the form of O2. And finally, we can approximate the remaining 1% as being argon. There are a few other elements in air, but we're just going to consider the three primary elements in air. So if we're given these percentages for the total volume of air, and we consider, say, 100 molecules, then we know that 78 of them will be nitrogen and 2 molecules, 21% will be oxygen, or 21 molecules, and then one of those molecules on average is going to be argon. So if we have these percentages, we need to know the masses of these three molecules, of these three elements. So N2, we have 2 nitrogen atoms, and each nitrogen atom has an atomic mass unit of approximately 14. So we have 28 AMU per nitrogen molecule. In the case of oxygen, we have 2 oxygen atoms, and each oxygen atom is 16 AMU. So we have 32 AMU per oxygen molecule. And finally, argon, we just have 1 atom, so we have 1 times the mass of argon, which is 40 AMU. Now, if we have 100 molecules of air, then we can find out the total mass of this air. So 78 molecules of N2 times its mass, 28 AMU, is going to be equal to 2,184 AMU. For oxygen, we have 21 molecules times 32, and this is going to be equal to 672. And finally, for argon, we just have 1 molecule, 1 atom, and that's going to be equal to 40. And when we add these up, we get a total of 2,896 AMU. So now that we have the total mass of the air and the masses of each respective element that composes the air, then we can find the percent by mass. So for nitrogen, percent nitrogen in terms of mass is going to be equal to 2184 divided by 2,896, which is approximately equal to 75.41%. Percent oxygen is likely also going to be approximately 672 AMU divided 2,896, and we end up with 23.2%. And finally, for argon, percent argon is going to be equal to, by mass, 40 divided the total mass, 2,896, and we get approximately 1.38%. So as you can see, these percentages by mass are very similar to the percentages by volume, but they are different. And this is how you calculate the percent by mass with the given percentages by volume in the case of air. My name is Walter Unglaub, and this is how do you find percent by mass with given percentages.